Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to take a closer look at the planet Uranus. I have gone through the other planets closer to the sun. If you take a look back on my channel, you will find a video all about Saturn, another about Mars, Jupiter, Mercury, Venus, not the Earth, of course, that may fall a little outside the realm of astronomy, but we are now moving further out to the first planet that we're going to look at that's not visible to the naked eye. So we can see Jupiter, Mars, Saturn, all there, all on the ecliptic. And of course, every planet follows the ecliptic. So Uranus has to be somewhere along this line, but this line goes the whole way around the Earth and the far side of the sun. So, for example, even though Mercury and Venus both are on that line in the sky, we're not able to see them at the moment because they're too close to the sun. The problem with Uranus is a little different. So we're going to move out into pristine conditions in the countryside here at sunrise, and we're looking quite late at night, early in the morning, depending on your perspective, to see these planets. Here, we'll be able to see these planets earlier and earlier as we continue moving into the year. So let's get out into the countryside. Uranus, I've never seen Uranus with just my eyes. It's out there by Mars at the moment. So over the past few days, Mars has appeared to move past Uranus. This is because Uranus is following the stars. As we move, the stars in the sky appear to move, and slow-moving planets like Saturn and Jupiter, and to an even greater extent, Uranus, they tend to follow the background motion of the stars because they're moving so slowly around the sun that we barely notice it. Whereas planets like Mars, Venus, and Mercury, they very often visibly move differently to the stars. We can see here that Mars, it's almost like Mars is holding its position above the east while everything else moves behind it. And that's because Mars is orbiting the sun reasonably quickly, and at the moment, it's still sort of moving away from us. The Earth is moving faster than Mars, but we still have to catch up before we can move past it and see it following the background of stars in the sky. Uranus orbits the sun much more slowly. So, for example, we're looking at sunrise over in the east here. Uranus isn't too far from the Pleiades. Let's very quickly have a look all the way forward to next year. Same time and date. There's Uranus still very close to the Pleiades. Saturn doesn't seem to have moved much, but Jupiter is way down there, Venus is there, Mars is nowhere to be seen. And this is because our orbit with these planets, it's not really in sync. As we move through years here, we can see that the planets are definitely moving differently to the stars, but we have to look at them over the course of years to see this happening. Uranus takes a long time to orbit the sun, and that's because it's so far away. So I'll remove the names of the planets here just to make things a little bit more obvious. I don't know if you can see a dot there. I can just about see a dot here, but I've never been able to see such a dot in the real sky, certainly not with some of the glow of sunrise coming up. So it has it here at magnitude nearly 6, reduced to a little more than 6 because of how low it is in the sky. That is definitely visible to the naked eye. Somewhere around 6th magnitude is absolutely visible. And we can see there, this star, 63, Arei, it's absolutely visible to the naked eye at 5.3, 6 point something, without the arrows there to point me in the right direction, it's practically impossible to see. So I don't tell people that they can rely on their naked eye to find Uranus. The ancient Greeks and ancient Romans had already discovered planets like Jupiter and Saturn, and they are very bright. But one of the main clues was the way they move through the sky. If we click on Saturn there, magnitude of nearly 1. If we click on Capella there, a magnitude of nearly 0. So some of the stars are brighter than some of the planets. Jupiter and Venus are the two brightest things we see in the sky besides the sun and the moon, whereas for Mars, for Saturn, they're not as bright. There are stars brighter than them. Mars distinctly moves over a short period of time, even over the space of a few days here, whereas those other planets take years to notice the motion of. Uranus will move over the course of several decades if we move through the years fast enough here. you'll notice that it does move. I'll get this kind of out of the way, bring back up the names to make it just a little bit easier to spot. There we go. And we'll see that as we move through years, Uranus absolutely moves across the sky. Its position absolutely changes. And the observations of these distant planets were done over the course of years by the ancient Greeks and ancient Romans, but they never noticed Uranus. We're going to take a closer look at Uranus here, and to make conditions absolutely perfect, we will get rid of the atmosphere so that we can take a closer look. Now, Uranus is closer to us than Neptune. It is a viable target through a telescope or binoculars. But this, we'll actually move back a couple of days. I'll see if I can make this comparison even clearer. Here we go. There's Uranus and Mars practically right on top of each other. And as we zoom in, we're starting to see some of Uranus's color here. We're still not seeing any detail on the surface of Mars. With a bigger telescope, you can see some detail on the surface of Mars. That will be enough to show Uranus's slightly bluish color. So if your telescope is good enough to see some of the details on Mars, you'll definitely be able to spot Uranus, possibly even a couple of its moons. But Uranus is really, really, really far away from us. Uranus isn't at its closest point to the Earth right now either. When Uranus is directly behind the Earth, it will be at its highest position above the south at roughly midnight, which during the summer for Ireland is really about 1:30 in the morning. But I have a previous video dealing with that disagreement between the times. So we can see here it's 19.5-ish AU from the sun, so about 19 times further from the sun than we are, because we are 1 AU from the sun, and its distance from us then is about 20 AU, and that's because it's still almost on the far side of the sun. So it's the distance from the sun to Uranus plus the distance from the sun to the Earth. When we are on the same side of the sky as Uranus, this number will be closer to 18 because, well, we'll be on the same side. It'll be the distance from Uranus to the sun minus the distance to the Earth. And we may get a chance to move forward and look at that in the near future. Taking a look at Uranus here, Stellarium is able to show us this very faint ring, but that ring is incredibly difficult to detect and wasn't discovered until comparatively recently. We can also see Uranus's kind of pale tealy color here. Recent images have indicated that Uranus is actually a closer color to Neptune, or that Neptune is a closer color to Uranus. They're both kind of bluish, and that bluish color comes from things like methane and ammonia in their atmosphere. As I mentioned in my ice giants versus gas giants video, the composition of Neptune and Uranus are just a little different from Jupiter and Saturn. Because Uranus was discovered so recently, it was the first planet where there was any argument about how to name it. Uranus didn't have an ancient Greek or Latin name when we discovered it, or when William Herschel discovered it. William Herschel was the discoverer of Uranus, so Herschel's planet was put forward as a potential name. Herschel instead proposed George's planet, or the Georgian planet, after King George, who was the king of England at the time. Eventually Uranus, or Uranos, was suggested, because Uranus, the titan of the sky, was the father of Kronos, or Saturn, who was the father of Jupiter, or Zeus. So because we already had a kind of a father-son thing, astronomers thought it would be fitting to have a father-grandfather kind of thing going on. So in order of the generations, you've got Ares or Mars, followed by Jupiter or Zeus, followed by Saturn or Kronos, followed by Uranus or Oranos. The difference between the Greek and the Latin there is a little bit more slight than the differences with Jupiter and Zeus and Saturn and Kronos, for example. So this was discovered much later, and when its moons were discovered, they were not originally given names from Greek and Roman mythology. Because Uranus was the titan of the sky, it was considered a good idea to name these moons after fairies, airy creatures, spirits of the air, sylphs, these kinds of things. So they got named after characters from A Midsummer's Night Dream by Shakespeare and The Rape of Loch by Alexander Pope. So that's where we get these names, even though they do sound appropriate. Names like Miranda and Ariel, Puck, Umbriel, Ophelia, these are all great names, and they do hark back, in many cases, names like Titania, they do hark back to Greek and Roman stories, or Greek and Latin stories, I suppose. But in reality, these names come from works of English fiction, so that's been maintained. There are only 3 named after characters from The Rape of Loch, Belinda being one of them, Ariel, I believe, being another, although Ariel is also a character in one of Shakespeare's plays. There's also a Margaret out here somewhere. It doesn't seem to be showing up, but Margaret from Much Ado About Nothing, another one of Shakespeare's plays, that's another name behind one of the moons of Uranus. So Uranus, very distant, very difficult to observe. Really, I don't think it's possible to observe Uranus with the naked eye, but not everyone is going to believe that. Some people are going to be certain that they can see Uranus, and I have to admit that there is a chance that their eyesight is just flat out better than mine. That is definitely a possibility. I do not have the best eyes. So we're going to move forward to the middle of the night, or that was towards daytime. We need to move back to around 1:30 in the morning if we're looking at it here in Ireland. And then we've got to go forward. I think we're after coming out of summertime by now, so I can actually pull us back to closer to midnight, about past midnight. And speed it forward a little bit, so it's actually past. Stellarium can be a little bit sensitive with the time sometimes. Somewhere around here. And there is Uranus right above the south, and there we go. 18 and a bit AU instead of 20 and a bit AU. So Uranus has now made its way all the way back around to there. And even better from this position, we would be able to see it changing where it is in the sky. If I bring back the atmosphere, Uranus is just that very, very faint dot. Very easy to mistake for a star. It won't twinkle, but honestly, without a telescope or binoculars, even that might not help you too much. So I hope you enjoyed this quick look at Uranus and how difficult it is to see and why it's so difficult to recognize compared to the other planets. If you enjoyed this video, I will have a similar video about Neptune in the near future, as well as previous videos covering the other planets in a similar way. So if you subscribe to my YouTube channel, you're more likely to see this video about Neptune that will be coming up. And you can also take a look back through my videos to see a little bit about these planets. You can also visit my website, creebeanscontent.ie, to read a little bit about them. Either way, I hope you enjoyed this show, and I hope that you come back next time.